Alright class, so what we're doing today is graphing secant and cosecant graphs, which is basically graphing sine and cosine graphs, but just doing a little bit more with them. So the first thing you have to do is identify what cosecant is the reciprocal of. So this is the reciprocal of sine. So that means we need to find the sine graph. Well, the good news is everything is the same as it was with sine. The parent function, the amplitude is still 1, it's the number in front. The period is still 2 pi for a cosecant curve, which means the interval is pi over 2. So what you have to do is graph sine first, but graph it with a dotted line, because we're not actually graphing sine with dashed line. Okay? So that's the first thing we're going to do. So I'm going to just graph a sine curve. We go pi over 2, pi, 3 pi over 2, and 2 pi. The amplitude is 1 and negative 1. So normally for a sine curve we start at 0 and then we go up, middle, down, middle. So I'm going to do this dashed, like I said, because we're not really graphing sine. I don't want to graph sine. So that's what sine is, okay? But we want cosecant, which is the flip of that. So here's what happens when you flip sine. Think about flipping 0. You guys know this already. When I flip at the midline, these are all the zeros. When you flip 0, you get undefined. So what happens is you get a vertical asymptote here. So you have vertical asymptotes at the midline. So vertical asymptotes at the midline, where it hits the midline. Okay? Now all you do to graph it is you start at the peaks and the valleys. So at pi over 2 we're at the highest point at 1, because when you flip 1 you get 1. But think about this, when I flip, when you guys agree like this is 1/2. So when you flip 1/2 you get 2 instead. When you flip 1/2 you get 2. So what happens is these curves look like this and go up forever to infinity. And then when you flip it, it's the same thing down here. We go down forever, but you start at the minimum point. So that is, so the the cosecant curve here is the red curve. That is actually the curve. Everything else is used to get that. So this makes the domain a little bit interesting for this. It's not all real numbers anymore, because wherever you have a vertical asymptote, it doesn't exist. So we would say, well, x cannot be 0, because that's the first one that it is that. And then it's every iteration, or every time we add, and if you have to look, every vertical asymptote that pops up is a pi away. So we can say pi times k, where k is just how many away you are from that. So whenever you want to just say it keeps repeating, figure out how much the spacing is and then times k. The range is also a little weird, because if you notice, the range goes all the way down to negative infinity and then up to -1 and including -1. Then there's no graph in the middle here where the sine curve was. There's no graph, but the graph starts again at 1 and goes up to infinity. So that's what happens with the domain and range. So let's look at the secant graph now, which is the reciprocal of, this should just say 1 over sine, not negative. 1 over cosine. Again, 1, 2 pi, pi over 2 for the interval. Same thing, graph cosine with dashed lines. So it's the same principle we just did with the last one. 1, -1, pi over 2, pi, 3 pi over 2. Because these don't have phase shifts or anything, so this is the standard graph. Draw the cosine curve. So cosine starts at the top, then middle, then bottom, then middle, then top. Do dashed lines. And then we do vertical asymptotes through the midline. So the midline hits at pi over 2 and 3 pi over 2. And now we can draw our curve. So the actual curve starts at the top, so the top starts here. Now when you have it like this, you can just graph, technically it goes like this and like this, but you don't need that part. It goes like this, and then here it just goes like that. You can do that if you want. Okay, so it's just like graphing cosecant, except for it just shifted over in a way, because we started at the highest point of 1, which shifts the domain. To do the domain, figure out where the vertical asymptote is. I see it at pi over 2, plus, and then again, the gap between pi over 2 and 3 pi over 2 is a pi, so that gap is still pi k. The range, we are all the way down at negative infinity up to -1, just like, actually this range is exactly the same as the cosecant curve. Okay, so basically everything you have to do is graph the original curve and then see what happens. Put the asymptote lines in and graph the new one. The domain's probably the hardest one, so we'll talk about that for this next one here. So I see cosecant, so I think I have to do sine first. I have a shift up 2 and an amp of 4. Now, because it's just x, we know that that's 2 pi and an interval of pi over 2, just like before. So if I graph this, that's 0, 1, 2, that's my midline, and then the amp is 4, 1, 2, 3, 4, so that's up at 6, and this is down at -2. Okay, so these are my 3 spots, 0, and then I have to do the tick marks, pi over 2, pi, 3 pi over 2, and 2 pi. Because again, there's no period change. Okay, so now I'm going to sketch the curve. I need a sine curve, so the middle line is here. So I'll put the dotted line there. So again, it starts here at the middle, then it goes up because it's positive, then back to the middle, then down at -2, and then back to the middle. So here's my sine curve. If this was a sine curve, you would be done right here. The next step is figure out where the graph hits the middle line. Well, it hits the middle line at the beginning, so I'm going to put a vertical asymptote. It hits it at pi, so I'm going to put a vertical asymptote. And it hits it at 2 pi, so I'm going to put a vertical asymptote. Now we just graph the graph. So cosecant, we start at the top of the sine curve and go up towards the asymptotes. And we start at the minimum and go down towards the asymptotes. So the red graph is actually the graph. Everything else was used to get it. So now let's look at the domain. The domain, there is no domain. X cannot equal 0. And then if you notice, every vertical line happens every pi again. So we're going to say plus any pi k. Because then I could put 3 in for k, that would be 3 pi, it doesn't work there. The range is a little different. Again, it starts at -infinity but goes up to the minimum, which is -2. Then it starts at 6 and goes up to infinity. Okay? Now this one's a little different because we have a period change. Okay, we have a period change. 2 is the amplitude. Secant, we want a cosine. So I'm just going to make a note that I'm graphing a positive cosine first. The period is equal to 2 pi over 2/3. So you flip that up and divide. You get 6 over 2 is 3 pi. So 3 pi is the period. And then the interval is equal to 3 pi over 4. Because you divide that by 4. Alright, let's see what happens. So there's no vertical shift. So I can just kind of go. So I'm going to just say that that's 2 and that's -2. I don't have to do tick marks because it's centered at 0. The midline is 0. There's no phase shift either, so it's an interval of 3 pi over 4. The next one's 6 pi over 4, which is 3 pi over 2. The next one is 9 pi over 4. And then the next one, so 3, 6, 9, 12 pi over 4, which is 3 pi, which we said was the end of our graph. So that works. Now we have to draw. We have to draw it as a cosine curve. Cosine starts at the top, then goes down, and then back up. Remember to dash this one, because this is not truly the curve that we want to graph. Okay. Now we put vertical asymptotes through where it hits the midline, which would be here and here. And now we can graph our curve. So remember, with this one, you can just grab the piece. You can also just do this if you want. I don't really care. Okay. Now we have to write the domain. So the domain's a little different because the period changed. If you look, we're at x cannot be 3 pi over 4. Sorry. Then you look plus, what's the gap between 9 pi over 4 and 3 pi over 4? It would be 9 pi minus 3 pi is 6 pi over 4, which is 3 pi over 2, and then you put a k. So again, I found the gap here. The gap is 3 pi over 2, which actually ends up being half of the period. So it's always half of the period. If you want to think of that, this is always 1/2 times the period. Okay? The range is from -infinity up to -2. union 2 up to infinity. Okay, so that is basically secant and cosecant. You know how to graph sine and cosine hopefully right now because we've spent many days on it. If you don't know, you should probably come in for help. But these are just flipping sine and cosine, so you graph those and then they flip. Alright, good luck with that and have a good weekend if it's Friday. Otherwise, I will see you guys later.